Hey, this is Jim Bergmann with MeasureQuick here today to go over a couple things on evacuation. We've had a lot of questions really since we started showing some things with the new Fieldpiece pump and some of the evacuation things we're doing. I just wanted to go over a little bit about some best practices on evacuation and just how to get things going the way that you really want to get them going. So, a lot of guys go out and the first thing they want to do is they go out and they buy a new pump. We had Fieldpiece send us out these new pumps at AHR, so we've been actually working with them quite a bit in the shop. And I know there's a lot of them on the market today, and if you don't understand what you're doing when you buy a pump like that, you're going to be disappointed because there's just some best practice things that you have to make sure that you're doing. If you don't do them right, you're going to end up with more questions than answers. Vacuum is not the easiest thing in the world to do. Sometimes, when we're doing an evacuation, we think it's just this real simple process, but the measurements are so critical in evacuation, and just little tiny leaks in your vacuum system or your rig or your pump can cause just all kinds of problems. So we're going to go through some of those things, some best practices, and just make sure you get the most out of the tools that you're buying. So the first thing that I really, when I buy a new pump, one of the first things I do is obviously make sure it's filled with oil. We've been working with these Fieldpiece pumps for quite a while. There's a couple things I really do like about them. This is an 8 CFM pump. It might be bigger than a lot of people need, but there's some features in it that just because they're there, this is the type of pump I would buy. One of the things I like about it a lot is the DC motor in there. The DC motor can operate, I think, all the way down to about 95 volts. So, I don't know how many times I've drug a 200-foot of extension cord across the roof, and by the time I get there, my pump has a lot of trouble starting. Because this can start at such low voltages, that's one of the reasons that I might pick it up. So one of the first things that I always do whenever I buy a new vacuum pump is I always want to test the pump out first and see what the ultimate pull down is. So I'm going to go ahead and hook a vacuum gauge up here, and we're going to hook this up to the 1/4-inch port. The 1/4-inch port on the pump is actually only intended to actually be used to test a vacuum pump. Honest to God, you really should never hook up your hoses to this to do an evacuation. This 1/4-inch port's only good for about 0.7 CFM, and this is an 8 CFM pump, so you're only using a tiny, tiny fraction of the pump's capacity if you're pulling through a 1/4-inch port on the pump, but we need this 1/4-inch port to actually test the vacuum and see what the ultimate pull down is. So typically what I'll do whenever I do one of these is I actually mark the pump with how many microns that pulled when I bought the pump. Because what happens here is when you first buy the pump, it actually hasn't all seated in and lapped in. And what's going to happen is over time, the vacuum should improve a little bit as things lap into place. Lapping just simply means that there's a round cylinder inside the pump. It's got the vanes that the vanes go against, and they're actually separated a little bit by oil there. So the oil is actually what's doing the sealing. But as things lap, as things get worn in a little bit, we actually will see our ultimate vacuum a lot of times go down, and that's what I saw in the case of this pump here. So I'm going to go ahead. I've got it actually hooked up to a BlueVac Pro. We're at 76,000 microns. I'm going to go ahead and reset this just so we don't have all this time on here. So I'm going to go ahead and restart the recording, and then we'll go ahead and start the pump up. Now when I flip the switch here, this does have a soft start, so it takes a second to start. And you can see it's coming down right away, and we're getting into a very low vacuum very quickly. So we're down about 76, 75 microns and coming down. We also can look at the graphing screen on this, and there's a couple of interesting things right here. This characteristic right here where it's coming down real quick, this is called viscous flow. Viscous flow is when the vacuum, it's more or less there's so much pressure in that micron gauge that the flow is just, it's coming out very, very quickly. And we're seeing that drop down very, very fast. When it gets into this curve right here, this is what we call transitional flow. And that's just a transition into molecular flow. And down here, we're getting into what's called molecular flow, which means it's just sort of flowing out molecule by molecule. Now, the pump will take a couple seconds to actually pull down to its ultimate vacuum. That's normal. And if you're going in and reading a book on vacuum, they tell you that you need to actually wait almost an hour before you can determine the ultimate pull down on a pump. So, we've only been a couple of minutes here, about a minute or so right here, and we're down to 17 microns. And this will pull down, if we let it go for a long time, all the way down to about 15 microns of vacuum ultimately when we're done. So you can see right now the pump's doing very, very well, and as a first step, this is what we'd want to do. All right, so now that we got the vacuum gauge tested, or the vacuum pump tested, we're going to go ahead and take the vacuum pump off. And one of the things you got to remember is whenever you're doing any kind of evacuation, you always want to keep all your cap support when you're not using anything in here. And one of the challenges a lot of guys don't understand is that there's always water vapor in the air. And we've talked about in the past absorption, and it's like you think about a sponge actually absorbing water. That's pretty typical, but what we get in vacuum is a little different property called adhesion, and or absorption means absorb into, adhesion means to adhere to. And water vapor will actually adhere to copper surfaces, plastic surfaces, rubber surfaces, and all those types of things. And depending on the type of surface it is, the adhesion can be really high or it can be really low. And we can, like with the hoses that AccuTools come out with, they have very low adhesion properties. They'll dry out very, very fast in a vacuum, but you get some other types of vacuum rated hoses, like these typical charging hoses we're seeing here, and it can take forever to get the hose dry and tight. Now we know that the vacuum pump here just pulled down to like 15, 16 microns, but let's look what happens when we attach just a regular old charging hose to it here. So I got a 1/4 inch charging hose, and I'm going to go ahead and just uncap this, and we're going to hook it up to our vacuum gauge. And you just saw, like I said, it pulled down to about 16 microns. And I don't have a ball valve or anything. This is just literally just a small section of hose here. And let's look at what the characteristics, how the characteristics change when we hook a 1/4 inch hose up to this. So again, just direct connect it up. I'm going to go ahead and I'll restart the graph again just because it's been running for a few minutes. So we'll restart the recording. I'll turn on the pump and we'll watch this pull down here. So you can see right away it comes down pretty quickly, but you notice that the curve right now, let me hit this miss on here. We'll just never show that again. You'll notice that the curve right here at 1,000 microns, before it went way down here and it started to curve, now it's starting much, much faster to curve. And again, this is our viscous flow right here. So this is where it's flowing down very quickly into transitional. And you can see how quickly, how little time it's been transitional flow, and it's almost going right into molecular right now. And we're only at 500 microns right now on that hose. So you can see this hose has a huge impact on the performance of that micron gauge. The pump could pull down to 16 microns. We throw this hose on here, just the hose, and look how much the decrease in vacuum is. Now this, again, it's not any problem at all with the pump. It's the hose that we're attaching to it. Now I'm going to take a vacuum rated hose that's designed by AccuTools. We're going to show you exactly the same thing and how that compares. So now we've gone ahead and we've hooked up a vacuum rated hose. This is a True Blue vacuum hose by AccuTools, and we're going to do exactly the same thing. I left the other graph up here, this 1/4 inch hose. I'm going to go ahead and kick this guy on, and we'll let this pump start up again, and we'll watch the characteristics and how this is going to change. So now you can see immediately how much farther down this hose is pulling. It's dropped down below the 500 micron range. We're already down to about 170, 168 microns. We're still dropping, but this transition is a lot longer here, and the micron readings are a lot closer to what we see on the right at a direct connection to the pump. Now there's always going to be some losses here, and we can't help but have some losses, and this is because the pressure, when you're drawing a vacuum, the pressure's dropping in this hose. So we're actually evacuating, we're degassing, we're dehydrating this hose, but look at the difference right here. We're looking at a micron range here that was about 500 microns, and now we're down, approaching below 100 microns already in about the same amount of time. So the hose performance is much, much better with that larger hose. Now, this is why this is so important. We want to take all the work that's happening right here at this connection, that was pulling about 16 microns, and we want to move it as close to the end of this hose as we can, because any losses that we have in our hoses then are losses that were going to occur in the system. So this is what is going to result in huge amounts of time savings. If I can take all that work that we're putting and put it at the end of the hose, then we're going to obviously achieve that vacuum a lot faster. Now, obviously in our industry, we want to get down and hold below 500 microns, which is the whole goal right here. If my hose just barely gets below 500 microns in this amount of time, how long do you think it's going to take for us to get the system down below 500 microns? Right here, I'm down at 77, 78 microns already, so that's going to allow my system to degas and dehydrate much, much faster. So one of the reasons that when we get into hoses, one of the reasons it's so important is the hose. If you think about what's going on in a vacuum, right? We're removing atmospheric pressure, and our atmospheric pressure on the Earth is about 14.7 psig, or 14.696. So that's the most pressure that we have to work with. I don't care if you have a 1 CFM pump or you got an 8 CFM pump. The most pressure that we can remove is 14.7 psig. So if you think about that, we're bound by physics. We can't draw any deeper vacuum than 14.7. Then we have to. Only way we get increased flow is larger diameter hoses. Now, if you just look at the end of these two hoses right here, I have a 1/4 inch hose and I have a 3/4 inch hose side by side. The 1/4 inch hose, you just look at the diameter and you think about like trying to suck, let's say, trying to suck a shake through a straw, right? If you have a little tiny coffee stir and you're trying to suck a shake through that coffee stir, it's going to be much, much harder than it would be through this large diameter hose, right? That's the whole concept right here, is because air, when we talk about these low pressures, we're in a vacuum now, we're talking about pressures that are tenths or hundredths of a psi. So the pressures are very, very low, which makes that air, in effect, very, very thick and very hard to move. So a large diameter hose is going to dramatically increase. Now, how much does it increase? Well, you take this 1/4 inch hose and you take this 3/4 inch hose. This 3/4 inch hose is 92 times faster than this 1/4 inch hose is as far as conductance speed goes. So, you know, we get into vacuum and best practices. One of the things that we see all the time, and we're seeing a lot of problems out there, is guys want to use a four-port evacuation manifold for evacuation. And let me just talk a little bit about that and some of the problems with that. Because number one, if you look at all these mechanical fittings, you know, we have valves on here, we have all the different hose connections on here. We have a lot of places in this thing that it can leak. Now, we already talked about, obviously, hose size, how important that is. And this is like looks like about a 3/8 diameter hose. So this might be a little bit better for evacuation, speed up your manifold. But now you've got, if you think about what's going on here, I've got 5-foot hoses, so I've got 10 foot of overall length on this. So I've got, you know, 5 foot of this 3/8 hose, plus I've got 5 foot 1/4 inch hose on each side. So I've got a huge amount of long, small diameter hose in here, which is going to cause tremendous amounts of restriction in our evacuation. Let alone all the hose issues here, I have tons of points on this thing to leak. I have connections at different ball valves. I have the mechanical ball valves and the cells. I have the manifold. I have the manifold valves on here. There's so many places on this thing to leak that it's ridiculous. Now, I'm not saying that this manifold does leak, but it's just leak potential. The fewer connections we have, the better. And this is where I think Fieldpiece really did a good job designing their pump. And this is I think, really some of the game changers out here. When you look at a typical vacuum pump, it may have a 1/4 or a 3/8 connection on there. It doesn't have a valve tree. Now, for years, if you've been in this industry for a long time, you know, we use a vacuum rated valve tree, and that's sort of integrated into the Fieldpiece pump. So when you look at all those connections on that 1/4 inch manifold, you look what we have here. This is a properly connected system. We have completely simplified this system and made all these connections much shorter. So now, what we're using right here is a vacuum rated connection. This is an O-ring seal on here. And this type of connection is going to be inherently lower leaks than a threaded connection will. And this is what we would use like in a commercial industrial evacuation rig. So it's tied in, it's tied directly into our core tools. So we go from 1/2 and 3/8 fittings, large diameter hoses, as short of hoses as are practical, into our tank. And then we have 2 core tools here to isolate the vacuum from the pump. Now, when we shut off this vacuum pump, one of the things you're going to notice is your vacuum is going to rise. Now, there's a check valve built into here, and that check valve is, you know, to keep you from pulling the oil out of the pump into your hoses, but it's really not a vacuum tight check valve. It'll slow the vacuum down, but it's not going to stop all leakage through a vacuum through here. It's not, and neither will your blank off on your pump. Blank off on pumps don't work with the hood either. So we always want to have a core tool on here to isolate the vacuum. And when I isolate these 2 cores here, I pull one down, one the other way. What I'm doing now is measuring vacuum on this tank here. I'm not looking at what's happening on my hoses, so it allows me to completely isolate my tank from my vacuum rig. And now I'm only looking at the true vacuum on the tank. You have to use core tools when you're pulling an evacuation. Now we'll talk a little bit more about core tools, because actually, you know, on the tank here we don't have valve cores, so we didn't pull valve cores out. And when we go out, we're going to do a system today. When we pull down a system, we'll talk a little bit about removing the valve cores. But the valve tools have two functions. One is to remove the valve core, and the second one is to provide us with a vacuum-rated valve to actually isolate the vacuum from the vacuum rig so we can actually measure true vacuum on the system. So we'll go ahead, we'll get this thing started up, and I'll show you what we're going to do. So we got everything all hooked up here. I'm going to go ahead, and what I've done here is I've installed a secondary vacuum gauge on my pump. And I always like doing this whenever I'm doing an evacuation because that allows me to see what's actually happening at my pump versus what's actually happening in my system. And if I want to isolate my core tools here, I can actually check my pump pull down, make sure I don't have a leak in my vacuum rig, make sure I'm getting a good ultimate vacuum on here. It's just a practice that I like to do. I'm going to go ahead and reset this because it's been running for a few minutes here. So I'll just restart the recording. I'm going to go ahead and start this up. And again, we'll let this get running. I got my tank valves all wide open here. Core tools are open. A lot of times when I'm doing evacuation, I just go through, make sure everything's snug on here, which are all good and tight. And the vacuum will take a few seconds to come down because we're going through a countdown on the gauge here. So we got to give this just a couple of seconds. And when it gets rolling here, I'll come back and we'll show you how things have gone. All right, so now we're down to about 433 microns. We've let this run. It's coming up on the 4.5 minute mark right here. Let's just look at a little bit and see what's happening on the micron gauge over here versus what's happening at the tank. So right here we're about 273 microns. We're over here, we're at about 400 microns. So we have about 100 and some odd microns of loss between the two. Not maybe 125 microns or so of loss in there. And if I go ahead, I'm going to valve this off for just a minute. So we'll just isolate this tank. You'll see that vacuum drop here. But I want you to notice this because I'm going to show you again what happens when we hook up a 1/4 inch manifold. So I got these two valves shut, and we'll let this run for just a second here, and I'll show you what the loss is. So now on this end here, I've got about 79 microns, and here I've got about 85 microns. So now we're sub 10 microns in change right now. So the losses between what the pump is doing and losses in my vacuum rig are very, very small. Again, what this means, I'm taking all the work that's happening here, and I'm putting it at my tank. And that's really, really important. So this is, because it's had 2 or 3 minutes to run here, we know these hoses are getting pretty dry here, but now you can see our ultimate vacuum is getting around 78 microns or so on our rig. So that's a very, very nice low established vacuum. Now I'm gonna open up back to the tank again for a minute, and then we'll isolate with the core tools, and I wanna show you the next step of this. So now that we know that, number one, our vacuum rig's tight, this allowed me to check our vacuum rig. And I got open to my tank. Now is when I want to use my core tools to actually isolate my vacuum. So when you turn the core tools, you want to turn them somewhat slowly on here because there's going to be a small amount of gas trapped in the core tool, which we saw right there when we isolated the vacuum. So I'm going to close those off, and now I'm going to let this start to just settle out. And you can see right here, this is what's called our vacuum decay. Now in our app, there's a little valve button at the bottom right here, and it's telling us that we're going to do a leak check. So I'm just going to leak check the system. And the first time it pulls up, it's going to tell you how to identify a leak versus decay rate. But here's what we're looking for. If we have a leak, we're going to get a constant rise like this. And if we have a tight system, we're just going to get this tailing off where it'll curve up and out. So we'll go ahead and close that out, and we'll see what our characteristic is. So now I'm in the leak test mode, and you can see that this has gone up. This is where I closed our core tools, and now it's just gone up and it's curved and it's flattening out. So this is a nice dry, tight system, and ultimately this is going to hold well below 1,000 microns. Now it's not below 500 yet, so we're going to want to restart our evacuation and let this dry out a little bit more. But this is what I was talking about with water adhesion. This tank has just been sitting around our shop for a while, so it's not 100% dried out. It's got water that is bonded to the, molecularly bonded to the surface of that tank, and that is what's creating this pressure that we're reading on our micron gauge. So in this case here now, what I do is restart my evacuation, and I tell my system here that my core tools are now open. I'm going to restart my evac. It's going to go back in, and we're going to let this pull a little bit longer until the system's dried out. And once it holds below the 500 micron target and passes our decay test, then we're good to go. All right, so now I've gone ahead, I just want to show you the comparison here, because what I did is I took off the True Blue evacuation rig, and I hooked up what we typically see in the field, the way guys might do evacuation. And this is if you have a 4-port manifold. So we could do it again with a 1/4-inch hoses. A lot of guys just use 1/4-inch for evacuation. Well, I'm going to give it the benefit of the doubt. We're going to use this larger diameter vacuum hose here, and then we're tied in with our regular service hoses. Getting vacuum core tools hooked up so we can actually look at the vacuum in the tank. Gauge here and a gauge on on the vacuum pump so we can see what happens. I left the old curve up here so you can see about how fast this pulled down. This is where I isolated off the tank so we could see what the pull down was. This is sort of our decay. So this is all the same stuff here, just hooked up again, and we're going to go ahead and restart that graph. So now pull back down again. Again, this will take a few seconds to come down. Note the time here. We're about 9. Actually, I have to restart the evacuation here. All right, so we've been running this vacuum pump for a little bit of time now, and I got this hooked up to a typical manifold. And remember, I wanted to show you how quickly we could get down with the standard manifold versus what we did with the with a correct type of a vacuum rig for this type of a vacuum pump. And take a look here. This came down to 403 microns in 5:01. Now we had a little bit of lead time there. I'll just give it that, but 5 minutes to get down to 403 microns. We're not quite past the 400 micron mark. Now, if you look at the graph here, this is 5 minutes, right? We started this here again. I'll get the exact time in just a minute, but somewhere around 11 minutes. And we're 40 minutes in, so 30 minutes plus to get down what we did in 5 minutes, now 30 minutes, right? So think about that for just a minute, how much time savings we have. Now, a couple of things you got to think about here is how much wear and tear do we save on our vacuum pump, getting that done in 5 minutes versus 30 minutes. And then how much oil have we saved? The longer the vacuum pump runs, the more moisture it's pulling out, the dirty oil's getting. How many oil changes can we save by simply having the right vacuum rig on the system? Now we're getting really close to crossing over here, and I want to show you another thing here is just our loss in our vacuum rig here. So we're at 408 microns on our tank right now, and if I look over here, we're at 123 microns on our gauge. So quite a bit of loss in this vacuum rig. We'll test it the same way in just a minute here once you get to 400 and some microns. Now it's going to rescale again, and I wanted to catch it before rescale so you can see the relative difference here. But still, that's absolutely huge right there. We'll take a look in just a second how much time that was. So we'll let this cross the 403 micron mark, and then I'm going to go ahead and close these core tools off. I'm going to just start to close them off. We'll see a small rise in the vacuum as we start to close them, and then we get this closed. Now we'll go through our decay test. Again, I'll tell it that it is, we're at a leak check, and that's going to rescale our graph here. I might have to reset my zoom here. So now you can see that we're, very slowly here, decaying here, but we're going to obviously hold under 500 microns. The tank's had a long time to dry out over a 30-minute period, but our vacuum's going to hold nice and tight. So now I'm going to go back here and take it out of the decay mode. We'll restart the evac test, and I'm going to do a similar test here where I'm going to open up back up my core tools here, and we're just going to pull down the vacuum rig so you can see the difference in how the rig responds. So now I'm just closing the valves of my tank, more or less repeating the same test we just did a minute ago. And what we're looking at here is, down here we pulled down into the, I want to say 70 some micron range. We could check it real quick. I'll just slide this over here. At the bottom there, we're at, oops, a little touchy, it's a narrow graph. At the bottom there, we're about 80 microns. And you can see here, if we scroll onto our rig, we're at 271 microns. So, what, 8 times 3 is 24. So we're 3 times deeper. And this is literally stalled out right here. And this is a flat line. It's not going to go much deeper than it's going here. And it's all lost in our vacuum rig. Where if you compare that to this trend here, let me zoom in on this little section of graph here for just a second. We still had quite a bit of drop, and this, if we let this run, I've seen this all the way down into the 20 micron range on the better hoses here. So again, when you're looking at all this kind of stuff and you're starting to understand what's happening in your vacuum, this rig stalls out at 270. That's it. That's all we're ever going to get out of it. So now you see the big advantage to having bigger hoses. Now again, let's check this. We're at 270 here. Let's see what we're at our pump. Our pump's at 99 microns. So let's say 100 microns. So we got and 70 microns on loss between here and here. And that's because, again, we're not taking all the work that's happening at this pump and moving it to this tank. And again, that's why you want to use the right size and right type of hoses every time you use your vacuum pump. All right, so now that we're getting this all wrapped up here, I hope you realize the importance of using the right tools for the job. And if you're going to buy this great Fieldpiece pump, how important it is to hook it up to the right size, right diameter hoses, using the vacuum rated core tools and a good vacuum connector to get a really nice tri-tight vacuum. As you can see down here, this tank's holding at 342 microns, and we have a decay rate between 0 and 0.1 microns per second. That's why this is flashing. It's uncalculable. It's so low. Nice, clean, dry, tight system. Again, if you take the time, you get the right products, you do this right, you'll get the most out of this pump, and I'm telling you, it'll be one of the best investments you've ever made. This is Jim Bergmann for Measure Quick. Thanks a lot for watching.